Okay, in this video, we're going to go through the 6.4 notes. So this is Introduction to Inverse Trig Functions. So we start out with our special triangles to go over this section. So in a 45, 45, 90 triangle, I know that this is the the A root 2 side, and this is the A side, and this is the A side. So if that is the case, then I want to figure out what A is. So if A root 2 equals 1, then A equals 1 over root 2, and I have to rationalize that. So A is going to equal root 2 over 2, and since these are A's, I now have they are root 2 over 2 and root 2 over 2. So let's just highlight in green the values I have for the sides. Okay, and then that one was given to us as a 1. All right, let's look at the next one. We're going to set these up first. This is a 30, 60, 90 triangle, and if that's the case, then this is the 2A side across from the 90 degrees. This is the A root 3 side across from the 60, and this is the A side across from the 30. So if 2A equals 2, because that value they gave us is 2, then A must equal 1. And that means that this side is 1, because that's the A side. This side is 1 root 3, and this side was 2. So let's highlight those as well. We'll highlight those kind of in pink. Okay, so there's a 1 for over here. It's a 1 root 3 here, and it's a 2 for here. Now I'm just going to copy these over here because I have the same values. So this is root 3, which is the same as 1 root 3. This is 1, and this is 2. And we'll make those highlighted in pink as well. Those are our values. Now, below them, we're going to figure out the sine of 45, the cosine of 45, and the tan of 45. So we're just going to do the main trig functions. So from 45's perspective, and knowing that everything pertains to SOHCAHTOA, the sine is opposite over hypotenuse, which is root 2 over 2 over 1. So I'm just going to write root 2 over 2 because putting it over 1 is not necessary. Okay, cosine, from cosine's perspective, I'm going to look here for adjacent, and that's also root 2 over 2, and the hypotenuse is 1 again. So I'm just going to leave that be. Let me just make this a little clearer. That is root 2. Tan, from this angle's perspective, is opposite over adjacent, which is root 2 over 2 over root 2 over 2, which is just 1. So those are the 45 degree triangle sine, cosine, tan functions. Let's now we'll do the 30 degree here. Looking for the same thing. Sine of 30, cosine of 30, tan of 30. Okay, from 30 degree angle perspective, sine opposite over hypotenuse, that's going to be 1 over 2. Cosine adjacent over hypotenuse, root 3 over 2. Tan opposite over adjacent, 1 over radical 3, which we will rationalize so that I have root 3 over 3. Done. Okay, last one. We're going to do it from 60 degree perspective. Sine of 60, cosine of 60, tan of 60. Okay? From 60 degree perspective, opposite is radical 3. Hypotenuse is 2. Cosine is 1. Hypotenuse is still 2. Tan is root 3 over 1, which is just root 3. Okay, so we've gotten all of the special angles. You should be comfortable with this. If not, go ahead back and listen to this again. Okay, the conclusions that we've drawn can be summarized in this table. Now, we've done 30, 45, and 60. We haven't done 90, so we're going to give you that information. If you were to convert these degrees into radians, for 30, you would get pi over 6. For 45, pi over 4. And for 60, pi over 3. This is what we just did. And then you know that these are inverse functions, and we know how to get them. You just flip over their partner function. If you flip over 0, this is really 0 over 1, you get 1 over 0, which is undefined. That's why we have the little dash. So all the dashes are undefined. So if I say dash, I'm going to say undefined. Okay, so we're going to use this table in a little bit. How about right now? Okay, so now your job is to figure out the sine of what angle is 1/2. So what I would do, I'd come up here and I'd say, okay, the sine of what angle is 1/2. So look down the sine column, and where do you have 1/2? So it looks like you're going to be here, right, at these values, either 30 degrees or pi over 6. So I'm going to do both of them. So I'm going to say degrees and radians. Okay, so it was 30 degrees or pi over 6 radians. All right, so let me erase that. And let's do the next one. This one says, where is tan? What angle has a tan of 1? So go down the tan column, which is right here. And here's your 1. Go across, pick up the angles. So they're either going to be in degrees, 45 degrees, or in radians, pi over 4. Okay, let's erase that. And let's do the next one. What angle has a cosine that's equal to radical 3 over 2? Go down cosine. There it is. Go across. Pick up your angles. Either going to be 30 degrees or for radians, pi over 6. And lastly, let me erase these. Okay, lastly, we're going to look at this. Tan of theta is radical 3 over 3. Go down the tan column. Pick up your angles that go with it. And our answers are either 30 degrees or pi over 6. So that's how you work backwards from the values to get your angles. I hope that was clear. Okay, let's go to the next page. Trig functions maintain some interesting relationship across the 4 quadrants. Use your calculator to find the requested values, rounding your answers to 2 decimal places. Okay, so you're going to have your mode is in degrees, and take float off of float and put it on 2. So when I plug this in, you should be getting the following. So see if you can get this. Make sure you can verify it, because then we want to talk about some interesting things. Okay, so I'm just writing this stuff down. I used my calculator earlier. Make sure that you can use your calculator to get these. Don't just copy down what I'm doing, because you would never be able to recreate this. Okay, again, I'm doing it to 2 decimal places. Okay, tan, I have 0.75, negative 0.75, 0.75, negative 0.75. Then I have 2.05, negative 2.05, 2.05, and negative 2.05. Okay, so what do I know? I know a couple of things. Let's look at the 37 degrees. 37 degrees is in quadrant 1, right? So this is in quadrant 1. Where is 143? Quadrant 2. 217 is in quadrant 3, and 323 is in quadrant 4. Okay, same thing down here. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, what kind of statements can be made? It looks like sine is positive in quadrant 1 and 2, but negative in 3 and 4. Okay, both cases, that's the case. Let's look over at cosine. Cosine is positive in quadrant 1 and in quadrant 4, but negative here and here. And what about tan? Tan is positive in 1 and 3, but negative here and here. These are the kind of patterns we're looking for. Look what I can get. This angle 37, we're going to call that a reference angle. And we'll do more about this in a second. But if I take 180 minus 37, guess what I get? 143. If I take some angle minus 180, and I'm going to get, this will be 37. If that angle is 217, look what I'm getting. So if this is 37, okay, 360 minus 37, so 37 is going to give me 323. Okay, so let me just make sure I've done this correctly. Yes, I have. Okay, so you're going to get a sense of these being important relationships, and we'll do more with this later. Okay, so this is going to be 244, and that is going to be 64 when I remove 296. Now, why is that? So the four angles that we're identifying, like right here and right here, are called symmetry partners. And the value of the angle in the first quadrant is labeled as the reference angle. So let me show you why just with the 37. Okay, here's 37 degrees. Now, look at this angle. You get it by going all the way around. I know 180 is here. This is your reference angle of 37. And what is that big angle? Well, that's 143. Okay, go to the next one. Here I'm in the third quadrant. This angle is 37. What is 180 plus 37? And that's going to be 217. And lastly, if I have a 37 degree angle right here, and I start over here and I go all the way around to here, what angle is that brown? Well, that's going to be 360 minus 37. And this is exactly what I'm doing here. Okay? So this is going to be minus 37, minus 64. And that's going to equal 296. Okay, so we're playing around with the symmetry here. For the moment, we'll focus just on supplementary angle pairs. So remember, these are supplementary. And where are they located? Quadrant 1 and quadrant 2. How come? Because the end of quadrant 2 is 180. Okay, so here's your 180. So if I have 37 here, this is going to be 143. If I have 64 here, then the big guy is going to be 116. So notice, the sine of 180 minus your reference angle is exactly the same as the reference angle. So try that with 180 minus 37 is the same as 37. But when you get to cosine and sine, it's going to be the negative of the cosine. So the cosine of 180 minus theta, and that theta, let's say it's going to be 64, isn't this the cosine of 116? And that's going to be the negative of the cosine of 64. Okay? So that's going to be the negative of that. Same thing's true with tan. If I do the tan of 180 minus 64, 180 minus 64, which is 116, that's going to equal negative of the tan of 64. We'll do more with this, but you can check it with your calculator. Okay, so here's some practice. All answers should be angles between 0 and 180. If sine of 38 is 0.62, there's another angle in quadrant 2 that also satisfies the sine of that angle is 0.62. What is that other angle? 180 minus 38 equals what? 142. That will satisfy. Okay, the cosine of 22. What angle in quadrant 2 will have a cosine that's negative 0.93? Well, 180 minus 22, that angle will be 158. And you can check this on your calculator. These angles are supplementary. If the tan of 64 is 2.05, then I know the tan of 180 minus 64, which is 116, will be negative 0.205. If sine is positive, then in quadrant 2, sine's also positive for its supplementary angle. And that angle in question will be 26 degrees. And lastly, if cosine is positive at 45, then the cosine in the second quadrant, which is its supplement, right, will be negative. So that's going to be negative root 2 over 2. Play with your calculator, see if you can get this. So what am I doing? I'm doing a couple of things. Here are the first two quadrants. Quadrant 1, quadrant 2. Okay, so in quadrant 1, sine of theta is y over the radius. Okay, opposite over hypotenuse. Cosine of theta is x over r, adjacent over hypotenuse, and tan of theta is y over x. Okay, so look at what's happening over here. Sine of 180 minus theta. So remember, this big angle from here to here is 180 minus theta. That's going to also equal what? Y over r. Cosine, you go back. Cosine of 180 minus theta will be negative x over r, and tan of 180 minus theta will be negative, well, will be y over negative x, right? So that's going to give me a negative right there. Okay, so the quadrant matters is where you want to come up against, and we're going to do a lot more with this, but that kind of explains how I'm getting the positive and the negative values. Okay, the x is negative in this quadrant. Therefore, anything that has an x in it will also go negative. Sine does not have an x in it. Sine's based on the y. and that therefore sine is positive in the first and second quadrants. Okay, first and second quadrants, sine is positive. Okay, let's work on a couple of more things. To this point, we worked with equations of the form, the trig of some angle equals a value. So the sine of 30 equals 1/2 would be an example. Okay, so I explained that some more. But we can work backwards. Look, you can say, instead of the trig, you can say the inverse trig of the value gives you back the angle. So using what I have here, I would say sine -1 of the value gives me back the angle. Okay, so what angle has a cosine of 0.437? What do? The cosine, this is the value, 0.437 equals some angle. Okay, so I'm going to stop there for right now. So hang on. Okay, so I had to walk away for a second, but I'm back at it. All right, so I'm going to use this on my calculator. Notice where that is. You're going to hit second and then cosine, and you'll get cosine -1. So cosine to the -1 of the value that I got gives me back the angle, and the angle is 64.1 degrees. Next one, what angle has a tangent of 1.46? That's the value. So to get the angle, I'm going to say the tangent, -1, of 1.46 is going to equal some angle. I put that in my calculator, and the angle I'm getting back in degrees is 55.6 degrees. What angle? What angles have a sine of radical 3/2? So, sine -1, radical 3/2, and that's going to give me an angle of 60 degrees. But then I say, okay, I remember that for sine, the second quadrant, those sine values are also positive. So in the second quadrant, if I put my 60 degrees here and I find out that that angle is 120, it will also have a sine value of positive √3/2. Okay, so that concept's kind of coming. Okay, it turns out that each of our big three trig functions have their own respective inverse functions, and we're going to use inverse functions to answer questions such as, what are the angles in a right triangle with side lengths of 6, 8, and 10? So that means if I give you the side lengths, you can use those to get me back the angles. A 24-foot ladder leans against a house, touching it 18 feet above the ground. What is the angle of elevation that the ladder makes with the ground? Again, I'm going to use inverse trig to get that angle. Identify two angles between 0 and 180 that satisfy the equation sine theta is 0.6. Well, I'm just going to say, okay, sine to the -1 of that value is going to give me an angle in quadrant 1. 180 minus that angle in quadrant 1 will give me the other angle in quadrant 2. Okay, so this is what we're working on now. The answers to all those questions lie in the inverse trig functions. We'll work with inverse functions in two ways in this section. We're going to use the reverse lookup from our special values table, and we're going to use calculators. Okay, so here's your calculator. Notice where the inverse functions are. They're highlighted in yellow, and to access them, we have to use the second key. So practice with this. I just want to have the quadrant 1 angles. So if I put in sine to the -1 of 0.5, and I'm in, my mode is degrees, so I want to be in degrees, then that means I'm going to get back an angle of 30 degrees. Cosine -1 of this value, because remember these are values, and these are the angles. I'm going to get back an angle of 45.0 degrees. This will be 25.0 degrees, 67.0 degrees, and 87.2 degrees. Okay, so we're only doing quadrant run right now. Okay, you make sure you can get these inputs on your calculator. All right, now let's work on solving a couple of problems, and then we'll be all ready to do the homework. Okay, the two legs of a right triangle have lengths 17 meters and 25 meters. Solve for the triangle. So draw your triangle. Okay, so this is going to be, I'm just going to make it 17 here and 25 here. As long as you put them on the legs, you're good to go. I'm going to label my triangle A, B, C. I'm going to see what's missing. I know that this is missing and these angles are both missing. Okay, this is little side C. To get little side C, I'm going to do Pythagorean theorem. 17 squared plus 25 squared equals C squared. I'm going to end up getting C is radical 914, and let's get a decimal for that. In my calculator, I say second radical 914, and I'm getting C is 30.2. This is 30.2. Okay, so now what I want to do is I want to work on getting my angles. So angle A, let's work on that. Angle A. From angle A's perspective, I can say the tan of angle A equals opposite over adjacent. Okay, there's my ratio. To get my angle, I'm going to take the inverse of 25 over 17 in my calculator in degrees, and I'm getting 55.8 degrees right here for my answer. Now, I could certainly say angle B I can get by saying 90 minus 55.8, and I'll get 34.2. That's fine. Or if you really wanted to use tan again, I can do the following. To get angle B, I could say the tan of angle B is 17 over 25. Therefore, angle B equals tan negative 1 of 17 over 25. And I believe I'm going to get the exact same answer. So I can either do inverse trig and get the answer, or because I'm only missing one angle in this triangle, and I know those two acute angles of A and B are complementary, which means they add to 90, I can just get the missing angle at that point by subtraction. Either way, I'm good with that. Okay, next thing. Okay, it talks about the CNN, the CN Tower in Toronto. So draw your right angle in the triangle, and this is your tower. So the tower is straight up and down. It says it is 500. Okay, this is 553, so change this to 553. Suppose that at a certain time of day it casts a shadow of 1100 meters. So this is where your shadow's going. What is the angle of elevation to the sun? You need that. Okay, so from that angle's perspective, I have opposite and I have adjacent. So I can say the tan of theta is 553 over 1100. So what does theta equal? Remember inverse trig, you're going to take the inverse of the value. In this case, the value is a fraction. And you're going to put that in your calculator, and you're going to get back in degrees, because I'm dealing in degrees right now, 26.7 degrees. And that's how that works, using inverse trig to get the angle back. Okay, we have just two more things to do. Okay, here we have a 147-foot cell phone tower. So again, draw your triangle. Here's my triangle. Let's fix this. Okay, here it is. And it's 147 feet. It needs to be supported by two strong cables. The first cable is placed on the ground 300 feet from the bottom of the tower. So I'm saying that this is the first stake that's going to connect that cable. Okay, so this is cable 1. The second cable will be placed 200 feet away in the ground from the bottom of the tower and will connect to a fastener located on the tower at a height of 97 feet. Okay, so I'm going to change my color, and I'm going to kind of move that 300 so that it's in a good spot. Okay, so I'm going to erase the 300 for right now, and I want to indicate in red that from here to here is 300. All right, and then they told us, I'm going to indicate it in blue, from here to here is 200. And what else did they tell me? They told me that from here to here is 97 feet. Which cable has the steeper angle of elevation? Okay, so the angle of elevations are here and here. And don't forget, this is cable 2. So it looks to me like we're going to use tan for both. Let's do the red first. So, and why don't we make this, so this is 2, this is 1. Let's call this A and this B. Okay, so I'm going to say the tan of angle A is going to equal 147 over 300. So A will be the inverse of that fraction. And so it looks to me like I'm going to get an angle. So angle A is going to be 26.1 degrees. Okay, so I'm going to change to blue. The tan of B equals 97 over 200. So therefore, B is going to be tan to the negative 1 of that value. And angle B ends up being 25.9 degrees. So which is the steepest? So it looks to me like this is the steepest. Okay, that's the steepest. So angle A wins. All right, one last thing. A right triangle has one side of length 11. So draw your right triangle. And I'm going to put my 11 over here. The hypotenuse is 19, solve for the triangle. So I'm going to make this ABC. Okay, solve for the triangle means finds what's missing. This is missing, that's missing, that's missing, that's a right angle. Okay, Pythagorean theorem tells me that, we'll do that first in brown, 19 squared equals little c squared over a plus 11 squared. So 19 squared minus 11 squared equals c squared. And it looks like that's going to be 240 equals c squared. So c equals radical 240. So in my calculator, I say second square root of 240. And I'm getting 15.5 meters. Okay, so this is 15.5 0.5 meters, and that's less than 19, so that's reasonable. Okay, let's now seek out our angles. So angle A. So what can I say for that? I'm going to use sine. The sine of A equals 11 over 19. So A equals the sine -1 of that value. So, and that's going to end up being, angle A will be 54, excuse me, not that. Let me see. So I'm trying to copy it from my other work, but I'm going to just do it again. Okay, so am I correct? Yes, that's good. Okay, so I'm going to say second sine to the -1 of 11 divided by 19, and I get back an angle, yep, of 35.4 degrees. Let me go back out of that. Okay, so this angle is 35.4 degrees, and that was angle A right here, 35.4 degrees. Okay, so then we're going to use blue to get angle B. I could just say 90 minus 35.4, which gives me 54.6 degrees, no problem there. Or if I really wanted to do some more trig, I could say that the cosine of angle C equals what? So 11 over 19, right? So the cosine of angle C equals 11 over 19. But I don't want that. So let me just write this better. This is cosine C. I want the actual value of the angle, so I'm going to take the inverse trig of that, and I will get the exact same angle I got by using subtraction. Okay, so I found both of those. So at the end of this lesson, you should be able to do inverse trig to find missing angles in right triangles. Okay, so that concludes this video.